Hello everyone, today we're taking a field trip to the sun, but don't forget your sunscreen. We're diving into the fascinating fiery world of sunspots. If the sun were a celebrity, sunspots would be its mysterious beauty marks. These aren't just dark spots, they're cosmic phenomena that have baffled, inspired, and occasionally terrified humans for centuries. So buckle up because we're going on a sunspot safari. Let's start with the basics. Imagine the sun's surface as a fiery ball of plasma, a bubbling, chaotic pot of hot soup. Sunspots are areas where things cool down a bit. Now, when I say cool, I don't mean you'd want to vacation there. These spots are about 3,800 Kelvin compared to the sun's usual surface temperature of 5,800 Kelvin. Cooler, yes, but still hotter than your oven at full blast. But why do they exist? Sunspots are created by intense magnetic activity. Think of them as areas where the sun's magnetic fields get all tangled up, like a set of Christmas lights in storage. This tangle suppresses the heat from below, making the area slightly cooler and darker than its surroundings. Sunspots often come in pairs because of the magnetic field. One sunspot will have a north pole and the other a south pole, like the sun's version of yin and yang. They're the celestial version of a buddy system. To truly appreciate sunspots, let's talk about their size. They can range from tiny, barely noticeable spots to massive areas larger than the Earth. Yes, you heard that right, larger than our entire planet. Some of the biggest sunspots ever recorded were over 50,000 kilometers wide. That's like lining up 4 Earths in a row. Feeling small yet? Now here's where it gets really interesting. Sunspots aren't random. They follow an 11-year solar cycle, swinging between solar minimums and maximums. During a solar maximum, the sun is basically throwing a rave. Sunspots everywhere, solar flares bursting out, and the energy level cranked to a max. During a solar minimum, it's more like the sun is taking a nap. We're currently in solar cycle 25, which started in December of 2019. Scientists track these cycles religiously because sunspots aren't just for show. They're linked to solar storms that can have real consequences here on Earth. More on that in a bit. Let's bring this closer to home. What do sunspots have to do with us? A lot, actually. These spots are often associated with solar flares and coronal mass ejections, or CMEs. Basically, giant blasts of energy and charged particles hurtling through space. When these particles hit Earth, they interact with our planet's magnetic field, creating a beautiful aurora. You know those breathtaking northern lights? Yep, you can thank a sunspot and its magnetic drama for that dazzling display. But it's not all fun and games. In 1859, there was a massive solar storm known as the Carrington event. It was so powerful that telegraph systems worldwide went haywire, with some telegraph stations even catching fire. Imagine if that happened today. Satellites could get fried, GPS systems might fail, and we'd have to live without Wi-Fi for a while. I know, it's horrifying, right? The takeaway? Sunspots might look harmless, but they're like the sun's warning signs for potential chaos. Humans have been fascinated by sunspots for millennia. The first recorded observations came from ancient China, where astronomers documented dark spots on the sun as early as 800 BC. But it wasn't until the invention of the telescope that things really heated up. In 1610, Galileo Galilei turned his telescope towards the sun and noticed these mysterious spots. At the time, people thought the sun was a perfect, unblemished orb. Galileo's discovery was a game changer. It challenged centuries of belief and even landed him in hot water with the church. Who knew sunspots could be so controversial? Speaking of controversy, there are also a period in the late in the late 1600s called the Maunder minimum. During this time, sunspot activity virtually disappeared for decades, coinciding with the Little Ice Age in Europe. While we can't say sunspots caused the colder climate, their disappearance seemed oddly timed. Today we've come a long way from squinting at the sun with primitive tools. Scientists now use spacecraft like the Solar Dynamics Observatory, SDO, to study sunspots in incredible detail. These observations help us understand space weather, which is crucial for protecting our technology. Here's a fun fact. NASA even uses sunspot activity to predict future solar storms. It's like having a weather forecast, but for space. So the next time your GPS glitches or your satellite TV cuts out, blame a sunspot. Here's some fun facts. A few little fun tidbits. First, big and temporary. Sunspots can last anywhere from a few days to a few months, but they fade away. They're like fleeting cosmic tattoos. When you see time-lapse video of sunspots, you'll notice they rotate along with the sun. The sun takes about 25 days to spin once on its axis, so sunspots get a nice little joyride. The largest sunspot ever recorded, known as AR 2192, appeared in 2014 and was so massive it could fit 10 Earths side by side. Imagine trying to explain that to ancient astronomers. Scientists have been counting sunspots daily since 1749. That's over 270 years of spotting spots. It's one of the longest running data sets in astronomy. Well, why should we care? You might be thinking, okay, but why should I care about sunspots? Well, sunspots are like the sun's mood swings, and keeping track of them helps us understand how the sun's activity affects our planet. For example, during periods of high sunspot activity, there's a higher chance of solar flares, or CMEs. These events can disrupt communication systems, harm astronauts in space, and even impact power grids. By studying sunspots, we're essentially giving ourselves an early warning system for space weather. And let's not forget, sunspots remind us that the sun isn't just a static ball of gas. It's dynamic, unpredictable, and full of surprises. So what have we learned today? Sunspots aren't just dark patches on the sun. They're windows into the complex and ever-changing nature of our closest star. They've sparked discoveries, influenced history, and continue to play a critical role in modern science. And perhaps the best part? They remind us that even the sun, its massive, powerful, life-sustaining star, has its blemishes. If the sun can rock its imperfections, so can we.